Welcome to this video. Welcome back if you came from the previous part. I'm going to finish up this calculator required portion of the multiple choice. I've been solving this practice AP Precalculus exam given by the College Board. Okay, so we left off on 82. Let's finish this up. There's only a few more problems. Function s is given by s of t is this guy, where k is a constant. If s of 4 is 300k, what is the value of s of 12? So they give us this value. We need to find k first, that constant. So how do we do that? Well, we have this, so we can say s of 4, which is 300,000. So I'm just going to write 300,000. One more zero, right? Okay, 300,000 is 500,000 over 1 plus 0.4 e to the k times t is 4. Because that is our 4 here, s of t, s of 4, so t is 4. Okay, so you could probably just use the calculator to find points of intersection and all that, but I'll show you how to do it by hand also. So by hand, but then we'll still need a calculator. Okay, so 300,000 over 500,000 is 1 over 1 plus 0.4 e to the 4k. Okay, so all these zeros you can actually cancel out. So 3/5 is left. Okay, and then I'm going to multiply by this 1 plus 0.4 e to the 4k is equal to 1. Okay, so I can multiply by 5/3 on both sides. Why do I want to do that? I would get rid of this. Okay, so 1 plus 0.4 e to the 4k is 5/3. Okay, subtract 1 on both sides. 0.4 e to the 4k is 5/3 minus 1, which is same thing as 2/3. Okay, and now we are going to divide by 0.4. So e to the 4k is 2/3 divided by 0.4. Now we natural log both sides. Okay, so like this, ln. Okay, so 4k would be, so this guy, we can plug into a calculator, but I'll leave it in exact form for now. It's ln of 2 over 3 over 0.4. So k would be, we just divide by 4 on both sides, so 1/4 ln 2 over 3 over 0.4, which is equal to, so we need a calculator for this. Let me even show you how I'm going to input it in my calculator app on my phone. It would be 1/4 is 0.25 times natural log of 2/3 of 0.4. So our k is 0.127706, something like that. You should store this in your calculator to get the exact form. Okay, or you can just plug this in. Or just plug this in when we need it. Okay, but I would just store this in the calculator because it's the calculator allowed section, required section they even say. Okay, so this is our k. We're not done yet. We want s of 12. So we found k. We have the general formula for s of t. So now we want s of 12. Okay, so it will be 500,000 over 1 plus 0.4 e to the k we found over here. So we store that in our calculator, hopefully. So k times 12. Okay, so now I'm going to show you how to plug it into my calculator even. 500,000 divided by parentheses 1 plus 0.4 e to the parentheses 12 times k. So my calculator, I could just do that. Close the parentheses. I get 1,7. Let me write it down. 1,75325, and the answer is A. Okay, that's how I would solve that one. Next, two function models K and M are constructed to represent the sales of a product at a group of grocery stores. Both K of t and M of t represent the sales of the product in thousands of units after t weeks for t greater than or equal to 2. If k is this guy, m is this guy, what is the first time t that sales predicted by the logarithmic model will be 0.1 thousand units more than the sales predicted by the linear model. Okay, so I'm going to graph both the functions and we'll see what to do from there. Okay, actually, you can graph k of t minus m of t. Okay, because, so you can graph these individually and kind of eyeball where it's 0.1 thousand units more. So actually, let me show that first before k of t minus m of t. Okay, so our function looks like this. All right, hopefully you can see on camera. Whoops, let me zoom a little bit. Okay, the red one is the log, the blue is the linear. Hey, we're only interested t greater than or equal to 2 even. So I can do something like this, okay? This is t is 2 down here. Okay, so we're only interested after that. We're interested when the sales predicted by the logarithmic model will be 0.1 thousand units more than the sales predicted by the linear model. So when is the red one greater than the blue one? For t is greater than 2. So notice when around t is 2, so if I can zoom in, sorry, I'm trying to zoom in for you over here. There we go, okay. So this is t is 2 down here, okay? You see that the blue is greater than the red. Remember, the blue is the linear. So we're interested when the red is bigger than the blue by 0.1. That's what it says. And if you kind of eyeball this, the answer should be 4 point something. Okay, and that's the only closest answer is B. So you can do it like this. And that's totally fine. You can also do k of t minus m of t. Why? Because if we take a difference of k minus m, we're interested when k is bigger than m by 0.1. So we can also do that. So we can see where this equals 0.1 and then see where the lines intersect. So let me show that also. Okay, so this is how it looks. The red one is k minus m. This blue line is 0.1, it's a constant. We're interested when the difference between k and m is 0.1, so after t is 2 again. So we don't care anything about before, after. And that's this point of intersection right there. And if I find intersections, you see that x is 4.3244, whatever, and that matches our answer that we picked. Okay, so that's just 2 different ways to graph it to see the answer. Okay, let's move on. Function f is given by 2 sine 4x plus cosine 2x. Using the period of f, which is following is the number of complete cycles of the graph of f in the xy plane on the interval x is between 0 and 1,000. Okay, so there's a very quick way to do this, okay, because we know the period of each one. Okay, so for sine of 4x, we know the period, capital T, is 2 pi over 4, which is pi over 2. Okay, for cosine of 2x, okay, this is a cosine, sorry. The period is T is 2 pi over 2, which is pi. So this cosine is slower. Okay, it takes pi in order to repeat again. So it's going to be limited by the cosine 2 pi. When we add both of them together, you can just imagine, well, this one, in engineering and physics, we call it superimposed on each other. I don't think you learned that in AP Precalculus, but you can imagine that when we add them together, it's just going to be, there's going to be 2 components. One will be this one, where its frequency is pi over 2, but there's another component where the frequency is pi. So this is the slower one, this is going to be the limiting one. Okay? Because within this interval, 0 to x, this cosine will have about half the number of cycles as this guy. How many completed cycles as this guy? Because this one is twice. The period is half. So the frequency is twice. If you remember, frequency and period are inverses. Okay, so we just divide 1,000 by pi. And what is that number? Let me plug it into my calculator real quick. That's about 318. We're going to round down because it's 318.3 something something something. So it only completed 318 cycles. So the answer is B. Okay. Graph of the piecewise linear function f is shown. Let g be the inverse function of f. What is the maximum value of g? Okay. Remember, inverses, you switch the y and the x. So for g, if we say, let's relabel the axis. Instead of x, it would become y, and instead of y, it would become x for g. Okay, so this is no longer the graph of f. Okay, I'm just relabeling the axis. So the maximum value of g is the biggest y value. What's the biggest y value? This is y. It goes up to 5. It's not defined for y is 6 and 7 over here. Okay, so the answer is C. As simple as that. Okay, moving on. Function f is given by f of x sine 2.25x plus 0.2. Function g is given by g of x equals f of x plus 0.5. What are the zeros of g on interval x is between 0 and pi? Well, we can use the graphing calculator for this question, so let's just graph the sky. So, let's graph g because we want the zeros of g, okay? So, we're just going to graph sine of 2.25x plus 0.2 plus 0.5 because g is f of x plus 0.5. So let me graph that real quick. Okay, got it. So you want the zeros between 0 and pi. Okay, so between 0 and pi, there's these two zeros. So let's find the roots. That's 1.54 and 2.47. Answer C. Multiple choice, you don't need to show any work. Okay, that's how I would do this one very quickly. Just use the calculator. Okay, and then the last one. Large wheel of radius 2 is rotated at a constant rate. Okay, this looks like a lot of words. Maybe we just got to pick out what's important, okay? This is always the tough part for most students. They get intimidated by all these words, but a lot of it is actually not needed. Okay, large wheel of radius 2 feet is rotated at a constant rate. The figure provides a representation of the wheel in the xy plane with the direction of rotation indicated. At time t is 0, the wheel begins to rotate. Point P on the wheel is at the start position in the figure. At time t is 20, 120 rotations of the wheel have been completed, and P is in the same position as it was at time t is 0. A sinusoidal function is used to model the y-coordinate of the position P as a function of time t in minutes. Which of the following functions is an appropriate model for the situation? So even just looking at the choices, what's the difference? Whoops. The period is the difference. So we only care about, actually, this sentence over here. Okay? Everything else is the same. Only the period is the difference. So how can we pick the period here? So see, why does 2 feet even matter? In this case, it doesn't matter. We didn't have to pick that. The amplitude is 2 because all the amplitudes are 2 here. So that wasn't necessary for this problem. So don't get intimidated by all these other sentences that don't really help you at all. It's actually here to distract you. Okay? So, as I was saying, we want the periods. How do we do that? Well, at time t is 20, 120 rotations have been completed. So we can get the period from here. So, period is in terms of time, in this case, minutes. Okay? So, we say the period is 120 rotations in 20 minutes. Or we can simplify it a little bit. It would be 120 divided by 20. That is 6 rotations in 1 minute. But period is how many, in one rotation, how much time it takes. So, because in one rotation, it goes back to the original point. That's the period. Okay, so we're not quite at the period yet here. We just did some simplification to simplify. So we want one rotation. How many minutes does that take? So we divide by 6 now. So one rotation, and 1/6 of a minute. So you could directly just divide by 120 on the top and the bottom to get to here. I'm just showing intermediary step if that helps you out to simplify. Okay, but you could just divide 120 by 120, which is 1. 20 divided by 120, that's a 6th. Okay, so we see that the period is 1/6 of the minute. T is 1/6. Okay, now we're not quite done yet because remember, if we have like sine of omega t, omega is the, we call it the angular frequency. I don't know if you learned that here, but that's the angular frequency, which is not the period. So t is 2 pi over omega, if you remember that formula. So we know t is 1/6, so we just need to find omega, and that's the difference in all these choices. We'll pick the right one. So how do we solve for omega here? It would be omega is, we multiply omega on this side, so it'll be omega over 6, so we multiply by 6. So 2 pi times 6, which is 12 pi. And that is choice D. Okay, and that's how we solve this last one. Hopefully this was helpful. Please like this video if it